The average yearly earnings for high school graduates age 18 and older is given by the linear function f of x is equal to 1,031x plus 25,193, where x is the number of years since 2000 that a person graduated. Let's look at part A. Let's find the average earnings in 2000 for a high school graduate. So to do so, remember, x is the number of years after 2000. Since I'm interested in earnings in 2000, we let x equal 0, and we find f of 0. So f of 0 is, let x be 0. That is 1,031 times 0 plus 25,193. So f of 0 is, of course, this is 0 plus 25,193. So the answer is 25,193. In the year 2000, those earnings were 25,193. Now look at part B. Find the average earnings for high school graduates in the year 2007. So the only difference for part B is now we are interested in the year 2007. What does that mean? That means now we let x be what? X is the number of years after 2000, so x will be 7. So here we find f of 7. And so that's 1,031 times 7 plus 25,193. And 1,031 times 7, that is 7,217 plus the 25,193. And if you find that sum, you will find that it is 32,410. So that's the earnings in the year 2007. Now let's move on to part C. Part C says predict the first whole year that the average earnings for high school graduates will be greater than $40,000. We want the earnings. Now remember, x is the year or years past 2000. F of x is earnings, so we want earnings to be greater than or equal to 40,000. This time for part C, to find that answer, we let f of x equal 40,000. And we're looking for time, so we solve for x. So here I'll use the same function, but instead of f of x, I write 40,000, and that equals 1,031x plus 25,193. Now, how do I solve this equation for x? I subtract 25,193 from both sides. If I do so, this minus 25,143 is 14,807. And that equals 1,031x. Then how do I finish solving for x? I divide both sides by the coefficient of x. 1,031, 1,031, and we will be approximating, it's approximately 14 and 4/10, but remember we're interested in the first whole year, so we will round up, we will round to 15. Now, what does that stand for? That stands for 15 years past the year 2000, so that means that in the year 2015, now where did I get that from? 15 plus the year 2000. In the year 2015, we predict that during that entire year, the salary is $40,000 or greater. That's part C. Let's look at part D. Find and interpret the slope of this function. First of all, what is the slope? The slope, this is written in slope-intercept form. The slope is the coefficient of x, which is 1031. What does the slope mean in this application? It means that the yearly earnings for high school graduates increases by this much per year. Remember, this is a rate of change. So again, what does it mean? It means the yearly earnings for high school graduates increases, because this is a positive number, by $1,031, and it increases by that, of course, per year. Now that's part D. What about part E? Find and interpret the y-intercept of this function or equation. So let's move to part E. What is, first of all, the y-intercept? All right, the y-intercept is 0, b, and b in this case is 25,193. There is the y-intercept. What does this mean? That salary was 25,193. So in the year 2000, what is this salary for? Yearly earnings for high school graduates. Yearly earnings for high school graduates was this number, $25,193.